couple of things that you can think about if you feel like, you do this. The first is, if I gave you a video and put it into Tracker, could you use that video to plot position points, then do a parabolic curve fit, and tell me what the acceleration, initial velocity, and potentially initial position of that object was? That is what this means. Could you do this yourself? If I give you a video and ask you, how quickly is this thing accelerating, could you answer that question using Tracker? And that's really the goal, because we're going to be looking at real objects moving, and they're going to have unknowns. I'm not going to be able to, I don't know how fast they're moving. I'm not going to be able to tell you how fast they're moving. You're going to have to measure it by taking a video. Okay? And then some things to think about once you feel like you've mastered that part. What if the acceleration was 0? What would those parameters look like for the parabolic curve fit? What if you had your ramp at different angles, or if you changed the masses of your cart? How would that affect the parameters that you're seeing? When you think about the last question on the activity, it's basically saying if you use the parabolic curve, you can figure out the acceleration and initial velocity. If you use the linear curve fit on the velocity data, you can find the initial velocity and the acceleration. Why would you choose one of these data sets over the other? Why is it that when you do this, and it will be different, why is it different? Why is it that you don't get the same acceleration? It's the same video. It only has one acceleration. Why is it that it's showing up differently if you look at position versus velocity data? And that's a really tricky question, but it's worth thinking about. And then here's some things you could think about. We could calculate acceleration and look at acceleration in a variety of different ways. We didn't always have videos and a video analysis software package to use. You could use the supercards to do it. How would you find acceleration using the supercards? What if you only had the motion sensor? Could you figure it out from that? What if you didn't even have that? What if you just had a ruler and a stopwatch? How could you figure out what this object's acceleration was? This is how, of course, people used to do it, before we had advanced technology. Like, if you wanted to know an object's speed, velocity, acceleration, you had to use a ruler and a stopwatch to do it. You didn't have any other way of doing it. So when you get past this place, all of these things are things that you should be thinking about. And this software package, I know it's a pain. It's new to us because the one that we used to use costs like several $100s per year. We can't afford it anymore. So this is the best free alternative. It isn't ideal, but it works. I mean, we can get it to work, and we know we can get it to work. And so I don't want the issue to be the battle with the technology so much as, can you figure out how to use it to get the data that you need? Because in the worst case scenario, we can get a video onto this computer. Once it's on this computer, if you know what to do, then you'll be able to get the information that you need. Okay? So I know a whole bunch of you are still working on this, and that's fine. That's where I expect most of you will be. And we're going to keep working on this on Thursday, so don't panic about not being done. But if you feel like you really got it nailed, there are some other things that you could think about. Okay, carry on.